Start. So welcome guys, welcome back to Chandu biology class. So in this class now we'll start with the topic measurements and errors. Okay. So the topic is measurements and errors. So in this, what is measurement and what is error? So if we measure something, any object, we'll say we'll measure the object. So suppose if I take an object and if I measure with 3 to 4 scales, like we have seen the rulers, no? We have seen the rulers. So I am taking 3 to 4 rulers, okay, and I am asking for a person to measure the object. So there is an object A, I am asking a 4 person to measure the object. So one person is saying 3 centimeter, one person is saying 4 centimeter, another person is saying 3 centimeter, another person is saying 3 centimeter. So different person, different measurement comes, okay. So I can say there is some errors made by the persons, and we will see what type of error also in the topic, okay. So first we will see what is the errors in measurement and least count. So if I consider a scale, no, there is a scale which is having, like in daily life we will use, no, from 0 centimeter to 30 centimeter. So what is the least count, what is the least centimeter I can measure from the scale? 0.1 centimeter. Okay, 0.1 centimeter I can measure. Okay, suppose I am taking a scale which is having centimeters only, like 1 centimeter. So I can measure only 1 centimeters, right? So this is 1 centimeter. So I can say this is the least count. So least count I can measure from the scale. So here it is 0.1. So the minimum amount of measurement which I can measure from the given instrument is called the least count, okay. And yeah, if I take a scale which is having, I am taking an object, okay, I have taken the object. Suppose the object has been measured like between 3 centimeter and 4 centimeter, okay. So which is the, okay, I will take the object like this, this is the object. So this is between 3 centimeter and 4 centimeter, okay. So which centimeter I can take, 3 or 4 from this? Which is nearest to the centimeter I can take, okay. If it is near to the 3 centimeter, I can say 3 centimeter. If it is nearest to the 4 centimeter, I can say either 4 centimeter. Either I can take only 1 centimeter, that is 3 or 4. Suppose the same scale is there which is having in 0.1 centimeter, okay, least count is 0.1 centimeter. This is least count is 1 centimeter, okay. Now the same thing, okay, the same object is there, it lies between 3 and 4. So I can measure exactly, somewhat the object is 3.4 centimeter like that, okay. So in this, how many numbers are there? 3 centimeter, 1 number. So this 1 number said to be 1 significant. And here it is 2 numbers, so 2 significant. Okay, so if significant increases, the accuracy increases. Here the accuracy was less, 3 centimeter and 4 centimeter, but in this case accuracy has been increased little bit. Suppose I am taking a scale which is having 0.01 centimeter as the least count. Okay, now if I measure, no, I am getting 3.46. So in this, how many significant are there? 3 significant. So from these 3, no, 3 centimeter, 3.4 centimeter, 3.46 centimeter. I have measured the same object, but I have got the 3 different values, but this having 1 least count, this is having 0.1 and this is having 0.01. So when I take the least count as the more, so the significant also increases, Yes or no? So if the significant increases, the value of the object, that is accuracy, also increases. So the point is here, more significant, more accuracy. Okay, this is the point. So when I take an object, if it is having more significant, the object will have more accuracy. Okay. So this is about the errors in measurement and the least count. Okay. So the if we measure a length, that is L is equals to 6.24 centimeter with the help of a vernier caliper. So vernier caliper is the instrument to measure an object. Then what is the least count of a vernier caliper? 0.01. 0.01 is the least count. So 6.24 centimeter, no? So 0.1, 0.01 is the least count. So how many significant figures are there in the measurement? 3 significant figures. Which digits are absolutely correct and which is doubtful in this? 6 and 2 also correct. Like if I take 0.001, no. So when I take 0.001, the number can change to 6.241, 6.242 up to 6.249. So the number is changing here. So here I can say 6 and 2 are the absolute correct value. 6 and 2 are the absolute correct value, and doubtful is 4. So there is one more example. If we measure a length of L is equals to 3.267 centimeter with the help of a screw gauge, then what is the maximum uncertainty or maximum possible error in the length? 0.001, because it is having 3.267, so 3 decimal, no? So I can take 0.001 as the least count. So least count can be said as uncertainty also, okay, or the maximum possible error. Okay, so 3 different name: least count, uncertainty, maximum possible error. So how many significant figures are there in the measurement? 4 significant, 1, 2, 3, 4. So similarly, which are the doubtful and which are the absolute correct in this 3.267? 3, 2, 6 are absolute correct values, 7 is the doubtful value. Okay, so understood in this? Yeah. Now the significant figure, they represent the digit in the number that contribute to its accuracy. So significant figures indicate how preciously a measurement is made. The more significant figure a number has, the more accurate the measurement is considered. Okay. Yeah. Now, so we have seen the significant figures like the countable numbers. So there is some rules to find what are the significant. Okay. Rule number 1: all zeros are all non-zero digits are the significant. Except 0, we can measure whatever number, those are significant. This is the rule number 1. Rule number 2: zeros appearing between non-zeros are the significant. Okay. So rule number 2, what they are saying, zeros appearing between non-zeros are significant. Rule number 3: trailing zeros after decimal places are significant. Like in the rule number 2, they have said no. Suppose if I take 1001, so how many significants are there? 4 significant, because zeros between non-zeros, so 4. So what about 1000? Only 1, because they have not mentioned as of now. Rule number 1, non-zeros are significant. Rule number 2, what they are saying, between non-zeros are significant. But up to rule number 2, if we take 1000, we take only 1 significant, because before and after zeros are not countable. Okay. Rule number 3, what they are saying, trailing zeros in the sense at last. Okay. After decimal places are significant. If I consider this 1000, no, instead of 1000, 1.000. How many significants are there now? 4 significants. Okay, 4 significant. So the difference between them is, if I add a point, the significant changes here. Okay. So up to rule number 3, clear? No? Yeah. Now the measurements are there, accuracy is there, and 6.4 centimeter. So accuracy will be 0.1, that is least count. 6.40 centimeter, 0.01 centimeter, 6.400 centimeter, 0.001 centimeter. If I see 6.4 centimeter, no, it lies between 6.3 and 6.5. How many significants are there? 2 significant. So 6.40, 6.39, 6.441. Okay, and 6.400, 6.399, 6.401. Okay, so here 2 significant, 3 significant and 4 significant. Okay, so if I see this, no, 6.4 centimeter, 6.40 centimeter, 6.400 centimeter. I have measured the same object, object A I have measured. Okay, so like the measurement 1, this is measurement 2 and measurement 3. If they are asking about the accuracy, so measurement 3 is more accurate than measurement 2. So measurement 2 is more accurate than measurement 1. Okay, so thus the significant figure depends on the accuracy of the measurement. More number of significant, more number of accurate. Like the significant increases, accuracy increases. Okay. Rule number 4. The powers of 10 are not counted as significant. So like we have seen, no, 10 power 1 or 10 power minus 1, 10 power 7, 10 power minus 9, whatever power of any number are not counted as significant. So if we say 1000, no, in the previous slide we have seen 1000. How many significants are there? 1 significant. I can write this 1000 as 1 into 10 power 3, right? So what is rule number 4 now? The power of 10s are not counted as significant. So I am not counting now. So the significants are 1. Rule number 5, if a measurement is less than 1, measurement is less than 1 in the sense, it will be in decimal, like in the points. Then all zeros occurring to the left of the last non-zeros are not significant. Like I will explain. We have seen that any number like decimal is there after trailing 0, no, trailing zeros are counted as significant. But if I take this 0.0001, so the number, non-zero number is there, no, 1. So before that any zeros are occurring, those are non-significant. Understood, no? Same thing, rule number 4 is there, no? Rule number 4 is there, 10 power minus 1. What is the 10 power minus 1 meaning? 0.1. What about 10 power minus 9 meaning? 0.00000001. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so how many numbers are there? 8. Yes or no? So these are not counted as significant. So rule number 4, rule number 5 and rule number 2 are almost same only. Okay, and yeah, example 0.0042 as only 2 significant because 4 and 2 are counted. If I take 4 to 0, how many significant? Then we have 3 significant. The trailing zeros I should count it. Rule number 6, change in units of measurement of quantity does not change the number of significant. So if I take kilometer, meter, centimeter, millimeter, 1 kilometer is nothing but 1000 meter, and if I 1000 into 1000 into 10 power, 1 into 10 power 3 I can write, no? So how many significant here? 1 significant. Here 1 significant. So if I convert centimeter, again 1. If I convert millimeter, 1. So the change in units doesn't change the significant values. We can write this measurement in other units also without changing the number of significant figure. So 7.2 centimeter has 2 significant figure, 0.072 meter, like I can write like this. So kilometer, meter, centimeter, millimeter. The conversions are 10 power 3, 10 power 2, 10 power 1. This is the conversions from kilometer to millimeter. Okay, if I want to convert from kilometer to meter, 10 power 3. Meter to centimeter, 10 power 2. Centimeter to millimeter, 10 power 1. If I want to convert kilometer to millimeter, 3 plus 2, 5, 5 plus 1, 6, 10 power 6. Okay. Similarly, if I want to convert millimeter to kilometer, no, in this direction it is 10 power minus 1, 10 power minus 2, 10 power minus 3. Okay. So 0.072 meter, 2 significant. Again 0.000072 kilometer. Okay, 2 significant. What about the last one, 7.2 into 10 power 7 nanometer? Okay, this also having 2 significant. So this is 2 significant and powers are not counted. The exponent values are not counted. Any doubt in this? Rule number 7. The terminal or trailing 0 in a number without a decimal point. So without a decimal point in the sense, the example we have seen 1000. So having only one significant value. So example is 264 meter can be written as 26400 centimeter.